Yes, thank you. So my name is Wout Hofman. I'm from TNO, but on behalf of the Ministry of Infrastructure and Water, is it water or water management? Water management. I will present the eGovernment Logistics Lab and what we did there in the eFTI support part. So looking at the eFTI regulation, as Simon already explained this morning, it's the authorities that need to accept documents in a digital way. So they have to accept freight information electronically. And that's currently only at physical inspection. That's the only way they can access it. And this will give, hopefully, a reduction of document production cost by business. What we have in the demonstrator for the eFTI support is that we will show that government can make use of data that is already shared by business. So they can piggyback on data that business already uses for their purposes. And this data provides access to source data, to additional source data. And it's all about transport orders, itinerary data, low discharge events, fire points as they are called when they cross a border. So that's to do with how to distribute data to different member states. And the core of this is, of course, the semantic model that we have developed. And what we will try to do is to integrate with whatever solutions there are used by business. So it's a transport management system, it's an onboard unit system, a platform, ECMR provider, large visibility platforms, whatever you have. And we will offer standard interfaces, and the standard interfaces are supported by what we mention a node, a basic data sharing infrastructure node. So this is the setup and this is a bit of the technical part. So what we did is we developed such a node, which is in the middle. And the node consists of the technical layer. We use a peer-to-peer blockchain technology over there called CODA. So CODA nodes share data with each other. CODA nodes construct the network. So when you install it, you log on to the network and you are able to share data with all others that have a node installed. So that's the technical data distribution. And on top of that, we've constructed the GraphDB as a triple store, which implements all the semantic data that is shared. So the semantic layer has all the semantic data and it's shared via CODA to other nodes. And in this particular case, to the Dutch authority and to the Belgian authority as a setup. It can also be used to share data with other nodes in the private domain. So other eFTI provider nodes, what have you. Let's see if it works. Yes. So what we have in the example is this type of simple scenario. It's a truck from its home base going to a warehouse in Belgium, picking up cargo, delivering it to a first store in Belgium, crossing the border, and to the second store, dropping off the rest of its cargo in the Netherlands. And we have used some sample data, of trip data of a carrier called Hessing to demonstrate how it would work. I will show that later on. This is sort of the flow that you have. What you see here on the left side is the TMS and the onboard unit that are already used to share data. So it's a truck driver that gets his orders, his itinerary, truck driver that reports of what he's done, load in a warehouse, discharge in store 1, discharge in store 2. And in the meantime, the TMS shares the data with the BDI node of the carrier, and that's copied to the BDI node of the Belgian authority and the Dutch authority. And then at a later stage, whenever something is happening on the side of the Dutch authority, he can ask for the data that's in the TMS. So he can ask for the transport data that's provided by the link in the events. I will show some screen dumps. So this is how we constructed the user interface of an authority. You see the logo of the Dutch authority. It's called the CMR data viewer. It better would be in this context to have an FT data viewer, because officially you're not interested in the eCMR, but in the Belgium case, they want to have an eCMR data viewer. So that's why it's called this way. So you can log on. It's linked to an identity provider set up according to the iShare protocols. Then you can request, you can enter a license plate. You can request for data. You receive the trip data. You can show the list of shipments in the truck. And then you can get the eCMR data per shipment, what happened, and the details in the end. So this is how you query your national node and get data from the system of the carrier. Now, some examples. This is the data we received. Nobody can read it, of course. So, but this is in OTM. This is how it looks like in the semantic model. So what happens is that there are lots of events created, and these events, they have a start, and the date is expected. This is how we have defined it in the model. So it's an expected, it starts, it has the timestamp over here. It refers to a digital twin, refers to the infrastructure, and has some other named individual. So all these events are generated from the OTM that we take. So what we could also do is take the examples of the ABSIS data, read it into the system, and then convert it into the model. Now, this is how the output will look like. So nobody can read it again. So you see a different structure compared to the input. Just lists of events. Now, on the technical side, you have the APIs. So now we go into the Corda part. You have the APIs, so like post events, get information on a digital twin, and so on and so on. So when you post an event, it's like this. So you have the data over here in the box. That's the RDF data, and the RDF data is shared as a string. So Corda, the technical layer, just shares blocks of data, of semantic data, to others. And there's a distribution rule over here to say that the countries involved in this example, it should be the Netherlands and Belgium, but it mentions Netherlands and Italy. Maybe that's for Andrea, he's Italian. So and in the end, what you get is this report. So a confirmation that the transaction is submitted to another node, and that data is recorded both on the ledger as submitted, and it's recorded in GraphDB. So this is the more technical stuff. So this is now what we're looking at. So we're trying to set up a network of nodes that are interconnected with each other, and they all fully implement the semantic model. So the semantic model is in the network, and these nodes are, as I explained. And on this node, there are what we call these endpoints. And on these endpoints, you can formulate whatever you want. So the nodes all talk the semantic language. They can interface, like I showed, to existing standards and structures, like the OpenTrip model, for instance, the EPCAs or whatever. And the output can also be in that format. So on top of this, you can build all types of user interfaces. This is the one we built for Dutch Customs. This is the one we built for road accidents. So you can have as many as you would like to have. We have seen all these different cases over here. So what we in the end are going to offer is a way by which you can formulate how you will use this infrastructure. So you configure it yourself by formulating your event structures. This is the more generic part for the eFTI. What we are now in the phase of, Lasse showed the hills, climbing the hills and going into the, going lower. So we're now on the first top of the first hill. What we're looking for and what we are actively seeking is contact with carriers, ECMR providers, onboard unit platforms, whatever, that would like to participate. That's on the one hand, and on the other hand, we're mobilizing the authority, the relevant agencies that have to use the data, that need to have access to the data. So this is the stage where we're in. Thank you.